We're going to take a closer look now at the simple discount note and the calculation of the interest, or that discount. That discount was calculated just like any other simple interest, I equals PRT. But you'll notice here the P, the principal that's used there, is that amount of money that's paid back at the end. They find that interest or that discount, they subtract it off to get back to the proceeds, which is what the customer actually receives for money to use. So because that interest is calculated off of the ending balance instead of the beginning balance, the effective rate of interest is much higher than it would be, or significantly higher than it would be if we had calculated the interest off the beginning balance. So what we want to look at here is converting that. What would be the effective rate of interest, or the equivalent rate of interest, if this were a simple interest note where the interest was calculated off that beginning balance instead of the ending balance? So one of the examples we saw in the last video was a customer who borrowed $4,200 at 6.8% on a simple discount note for 90 days. Then we used our formulas to find the discount. That's just I equals PRT, so that was the 4,200 times 0.068 is the rate, times, we're going to assume ordinary since it's not stated as exact, to give us this discount amount of $71.40. So again, that represented the rate off the ending balance, the amount that's paid back at the end of the term. So to convert that to what would be an equivalent rate for a simple interest note, or based off of the beginning balance, we're going to go back and we're going to calculate using I equals PRT, looking for now this rate. So the amount of interest is that discount, the $71.40. However, the principal we're going to use is not that face value of $4,200. We found a proceeds. That proceeds was found by taking that face value and subtracting the discount. And that proceeds was $4,128.60. That's the money the customer actually receives to use. So we're going to use that as our principal for calculating the rate of interest. Now the rate is what we're looking for, and our time is still 90 days, 90 out of 360. So the first step I have to do here in calculating is I have to combine the $4,128.60 with the 90 over 360. Giving us $1,032.15. Now we'll solve our equation here by dividing by the $1,032.15. Now in many cases when I combine those proceeds with that time, I might get a really long decimal, probably a continuing decimal or repeating decimal. In this case, I got a nice decimal. I can write that down and type it back in and not worry about round off. But in many cases, I can't. It's going to be long, so if I write it down and type it in, it's going to be rounded. One way to make sure that we don't round it to where it throws off our answers, we can make sure we go to 5 or 6 decimal places in that. Or I'm going to use a trick here where I'm just going to leave it in the calculator. So our calculation here, we have $71.40 divided by the $1,032.15. I'm going to type in the $71.40 and divided by, notice the 1,032 is my previous answer, so I hit second, ANS is previous answer. So it divides it out, and I get 0.06918. We always go to 5 decimal places or more on this rate, because we're probably going to round, usually round to the nearest hundredth of a percent. So 100th of a percent is once it's converted to a percent, it's to 2 decimal places. So we go a minimum of 5 decimal places when we record this answer. 0.06918 is what that'll round to. That's our rate. So now we move the decimal point to make it a percent. 6.918%, rounded to the nearest hundredth, that would be right there. That's 6.92%. That is the effective rate. So what that is saying is, if this were a simple interest note, where we started at the beginning with a principal, in this case, what we started with, what the customer actually received, was that $4,128.60, and the ending balance, what was paid back, was $4,200. The amount of interest that would have been added in would have been 6.92% of that beginning amount. So it is the equivalent interest on a simple interest note, or what's referred to as the effective rate of interest for that simple discount note. Another example we did was we did a savings bond. And that savings bond had a face value of $500. And it had a stated rate of 4.9% for 6 months. And we found, calculating that out, I equals $500 times 0.049 times 6/12 for 6 months. We found the dollar amount of the discount there to be $12.25. Subtracting that from the face value, we found the proceeds, or what actually was paid for that bond, to be $487.75. So the stated rate of 4.9%, again, is calculating interest off of the ending balance. The effective rate is actually slightly higher than that. So we're going to use the formula I equals PRT again, but we're going to adjust it using $12.25, our discount, as the dollar amount of interest. Our principal, though, instead of the face value, we're going to use the proceeds, $487.75. We are looking for a rate, and our time will still be 6/12. So once again, we have to combine that proceeds with our time factor. Giving us 243.875 times R. And we're going to divide to solve for R. So 12.25 divided by that 243.875. This 0.05023. Remember, we go to 5 decimal places. Equals R. We convert that into a percent by moving the decimal point 2 spots. 5.023%. And again, if we're not told, if it's not specified where to round, we're going to round to the 100th of a percent. That's 5.02% is the effective rate. So that is calculating the effective rate of a simple discount note.